Hi guys, let's take some notes. We're going to talk about the law of 10% first. The law of 10% says that 10% of the energy that is stored in the organism is used in the next organism. Only 10% of the energy that an organism eats actually gets stored in the next organism. 90% of that energy is not passed on to the next organism. And that could happen for a number of different reasons. That energy could get used up by the organism. So you use energy all the time for cellular respiration, to make ATP, to do all your life functions, move, grow, reproduce, just maintaining homeostasis uses energy. Some of that energy gets transferred to waste. So you can't absorb all the nutrients from everything you eat. Think about fiber. So some of that gets leaves your body in your poop. And then some of it you just don't eat in the first place. Like you don't eat the bones, you don't eat like the feathers of a turkey, you don't eat the feet, you don't eat the like the head. So there's a lot of it that you just don't eat in the first place, and then some of the rest of it, you can't actually break down, so it goes into your poop. And then a lot of the rest of it gets transferred into heat. So all of that makes up 90% of the energy that gets eaten by an organism. So it gets used, it gets transferred into waste, it doesn't get eaten in the first place, it gets transferred to heat, and then only 10% of it gets stored in the organism. So here's some examples. Um, if you look at a food chain, let's suppose that 88,000 calories get stored in grass. Then when mice eat the grass, only 8,800 calories are going to be stored in that mouse. That's 10%. 10% is easy. You don't even have to use a calculator. You just drop one of these zeros to figure out 10%. And then if a mouse eats the snake, of those calories that it got from the grass, 880 of those calories get passed to the snake. And then when the hawk eats the snake, of the original calories consumed by, or stored by the grass, 88 calories get stored in the hawk. All right, so you drop a zero every time, and you see that as you go down a food chain, you get less and less energy stored in each successive trophic level. That's the reason why trophic or food chains can only be so many trophic levels long, usually like four to six trophic levels long, because the energy gets less and less as you go down the food chain. Let's talk about biomagnification, or sometimes it's called bioaccumulation, the same word for, or different word for the same thing. This is when toxins get passed down a food chain. So with this one, it actually the opposite happens. Energy decreases, but the amount of toxins will increase. So this is the amount of matter available to the next organism decreases. Like energy, you've got less energy and less matter as you go down a food chain because it gets used up or gets lost as waste. But toxins, not all of them, but some of them can be stored in your fat. So then you're not using it, you're storing it, because that's what you do with fat. A lot of it, you store it. And so then it does get passed on to the next organism. And then it can actually accumulate or build up as you go down a food chain. So bioaccumulation or magnification means it gets magnified as you go down the food chain. So the definition is that it's when chemicals build up in an organism and then they build up as you go down the food chain. The amount of toxins increase in the food chain instead of decreasing like matter and energy do. Let's look at an example of this. One of the biggest, most common examples of this is the accumulation of DDT. DDT is a pesticide that is used Not anymore, at least not in the United States, but it's still used in other countries. We realize that it makes the eggs of osprey and eagles soft, and so then their offspring die when they get high concentrations of DDT. And they weren't directly getting it, but this DDT gets into the water supply, and then producers end up taking it in because they're in the water. Water plants that grow in the water take it in, and then zooplankton that eat producers take it in. So now they are eating lots of those producers, and so then they're hanging on to a lot of the toxin. Small fish eat a lot of zooplankton, and so now the small fish have lots of DDT in them. And then large fish will eat a lot of small fish, and you've got even more DDT. So then you've got the eagle at the top of the food chain, or the osprey. They both eat large fish. They eat these large fish, and they get an even higher concentration of DDT in them. And then it makes their eggshells soft, and then their offspring die. So you can see that unlike energy going down as you go down a food chain, toxins like DDT will increase until you get to the last, the top carnivore, and it'll have the highest concentration. Another problem that's still a problem. Well, DDT, it can be a problem in some areas, but we're solving that problem. Mercury, though, we're still working on. So mercury has some natural sources. Mercury can get into the water by volcanoes, but most of it comes from coal power plants. So it gets into the air. It can also be caused from mining. It can run off out of a mine into a water source. So it gets into the water through methylmercury, and then same type of thing. So you've got krill absorbing it, and then salmon taking it in, and then tuna eating salmon, and then your carnivorous fish like sharks, pike, albacore, halibut will eat the tuna and get the highest concentration. So you might maybe have noticed that it's recommended, especially that pregnant women don't eat a lot of these fish. Swordfish would be in here too, shark, pike, because they have really high levels of mercury in them. And even tuna, this is like canned tuna here, can have mercury in it too. It's good for you, but they recommend you only eat it a few times per week versus like every single day. So you limit your mercury consumption, right? Because you've got humans here a lot of times at the end of this food web, but if you eat farther up the food chain, like if you eat salmon or sardines, a smaller fish that doesn't eat carnivorous fish, that isn't at the end of this food chain, then you'll get less mercury. Because remember, these toxins bioaccumulate or get biomagnified as you go down the food chain.